Okay, so for lesson 6, we're talking about scatter plots and line of best fit. A scatter plot is just another way to display numerical data between two variables. So if you look down at this graph here, it says, does studying for the final exam really help your score? Does one event really affect the other? Well, if you look at the scatter plot, it shows that the longer a student studies, the higher their score. According to this survey of 15 students studying for the same examination, it appears that the answer to the first question, does studying affect your score? And the answer is yes. Okay. Notice how the data in this graph sort of represents a straight line rising from left to right. When working with scatter plots, it is often useful to represent the data with an equation of a straight line. We call this the line of best fit, or a trend line. And this line, which we'll get using our calculator, may pass through some of the points, none of the points, or all of the points. So linear regression. The data that appear to have a linear correlation or a linear relationship, like we just saw at that table, well, we can approximate them using a line of best fit or a trend line. The line of best fit will be a line, so a linear equation of y equals mx plus b. So we'll have a slope and a y-intercept. And this line of best fit will allow us to predict changes in the dependent variable, or y value, from changes in the independent variable, or x value. The slope of the line will depend on whether the correlation is positive or negative. The y-intercept will help us to understand the predicted value of y when x is 0. So we talk about the slope of the line will depend on whether the correlation is positive or negative. Well, if you look here, we have types of correlations. Here we have a negative correlation. And that would mean that the slope would technically be a negative. And that means as x increases, y decreases. You could have a positive linear correlation, which is what we had on the top of this page talking about the time studying and the grade. The positive linear correlation would mean your slope is positive, and that's as x increases, y tends to increase. You could have something over here, and there's no correlation there. Or finally, you have one over here, and it's a non-linear correlation. Before we get into an example, just one more thing is that two variables can have a very strong relationship with one another. However, that relationship may not be a causal relationship. A causal relationship exists when the change in one variable actually causes the change in the other variable, or one of them is a primary cause. So let's see what that means. Let's look at this example. It says in each of the following scenarios, two variables are given that if plotted would have a strong correlation. That would mean that our dots on our scatter plot would almost form a line. We want to determine two things. One, we want to determine if it's a causal relationship, and if it is, what variable causes the other. So let's look at A. The high temperature in New York City and the number of bottles of water sold. Do you think there's a causal relationship between these? Does one cause the other? And the answer is yes, there is a causal relationship between these. So the question is then, which variable causes the other? Does the high temperature cause the number of bottles of water to be sold? Or does the number of bottles sold cause the temperature to increase? Well, I hope you agree that the temperature causes the water to be sold. The higher the temperature, the more waters that are sold because of that high temperature. Look at the next one, B. A person's height and a person's shoe size. Does one cause the other? This one's a little tricky. And the answer is, the answer is no. There is not a causal relationship because someone's height does not make their shoe size increase. Okay, they may be related to something else, but the height does not make your shoe size increase and vice versa. Let's look at C. A person's weight loss and the number of hours a person spends at the gym. Does one cause the other? Well, the answer here is yes, there is a causal relationship. Take a moment and think, which one causes the other? Does your weight loss cause you to go to the gym, or does going to the gym cause you to lose weight? The answer is that going to the gym will cause you to lose weight. And finally, D, the years of education a person achieves and the salary that person starts at upon entering the workforce. Is there a causal relationship? The answer, once again, is yes. Which causes which? Does the years of education cause my salary? Or does the salary cause my years of education? And I hope you would all agree that the education causes my salary. Okay, how much education I have determines what my salary will be. So I'm going to stop this video here. Take a moment, okay, and we're going to look at example 2 together. And for example 2, you're definitely going to need to have your calculator. So I'm going to stop this video, take a moment. When you're ready to continue, I'll meet you on the next video.